Imagine a signal that keeps changing its frequency hundreds or even thousands of times every second. This type of signal is called frequency hopping spread spectrum, or FHSS. Now, the question is, how do we detect such a fast-changing signal? And more importantly, how do we stop it? This is where a smart system using software-defined radio, or SDR, comes into the picture. At the heart of this system is a small device called the Pluto SDR. This device works as both a receiver and a transmitter. That means it can listen to signals from the environment and also send signals when needed. Think of it like a smart radio that is fully controlled by software. To capture signals, the system uses an omnidirectional antenna, which listens to signals coming from all directions. And for jamming, it uses a directional antenna, which focuses energy in one direction to block communication effectively. Now, let's understand how the system processes signals. All the processing is done using GNU radio software. First, the SDR receives signals from the air. Then, using something called FFT, the system converts the signal into a frequency view. This helps us clearly see which frequencies are active. But here's a challenge. Real-world signals are always mixed with noise. So how do we know which signal is real? The system solves this using an adaptive threshold. It continuously measures the noise level and sets a smart detection limit. Only signals above this limit are considered real. Once a signal is detected, the system extracts important details like frequency, time, and bandwidth. All this information is stored in a file. Now comes the most interesting part, jamming. The system reads the detected frequencies and starts transmitting noise signals on those same frequencies. This effectively blocks the original communication. When tested in real conditions, the system showed very good performance. At moderate speeds, like 100 hops per second, it detected all frequencies easily. At very high speeds, like 1,000 hops per second, it became more challenging, but the system still managed to capture all frequencies over time. In real-world testing, the system successfully detected and jammed an actual frequency hopping signal. To understand this simply, imagine a person jumping between rooms very fast. The system watches all rooms, notes where the person appears, and blocks those rooms one by one. That's exactly how this system works. In summary, this SDR-based system can detect fast-changing signals, analyze them in real time, and apply targeted jamming. This makes it very useful for applications like defense systems and spectrum monitoring. And the whole idea can be summarized in one simple line: detect, record, and jam. This content is sourced from research paper Șorecău et al., SDR System for Real-Time FHSS Detection and Jamming, KBO 2025.